Okay, guys, welcome to the last video of how to manually uh, conduct a t-test, right? So we've discussed we've discussed one sample t-test, we've discussed two sample independent t-test, and we've discussed two sample paired t-test. Now we're looking at one sample t-test where we want to test for a proportion. And let's go ahead and take a look at it. Says a researcher wants to determine if a new advertising campaign has increased the proportion of people who are aware of a certain product. So we do a random sample of 500 people, 260 of them are aware of the product. We want to test the hypothesis that the true proportion of people who are aware of the product has increased from a previous rate of 40% using the 5% significance level. So how can we go ahead and do a test for proportion using the t-test? So the answer is you cannot. You do not use the t-test to test for proportions. Okay, and this is definitely a trap that you can fall into and that you don't want to fall into when you're doing your analysis, when you're doing your exploratory data analysis. So let me explain why you shouldn't use a t-test as a test for difference in proportions. So number one, we've got to look at the t-test assumptions, okay? So the assumptions of the t-test are, first of all, that we have our data is randomly sampled from a normal distribution. So our data has to be from a normal population. Okay, so that's our first assumption. When it comes to other assumptions, we need to have, of course, normality, independence, and equal variances for two sample t-tests. So all of these assumptions must be true in order for us to consider our t-test valid, right? Now, when it comes to a proportion, the proportion is bounded between 0 and 1, right? Because we're talking about out of 100. So out of 100%, right? So the difference between a proportion and a normal distribution is the normal distribution can vary from negative infinity to positive infinity. Now, if you talk about using the z-test for proportion, that certainly is possible. And it's possible because of the central limit theorem. Now, if you have certain conditions met for your proportion, so in other words, if your proportion meets the criteria that it follows the binomial random variable, meaning that you've got a certain number of n trials, you have the same probability of success, or the same probability for p for each one, and you have, if you multiply the number of trials to, so when I say trials, I mean like each person you ask, right? In a situation where you're trying to figure out how many people are aware, asking one person would be one trial, right? So are you aware of the product? Yes or no? That's one trial. If they say yes, that's a success. If they say no, that's failure. So every time you ask a person, you've got the same probability of success or failure, right? And then the other requirement is that if you multiply the number of trials times probability, it should be greater than 5. So in a way we can approximate a binomial random variable, which is what a proportion is, by a normal random variable. But when it comes to the t-test, we're going to have problems because the mean and variance of the sample drawn from the normal distribution, so those are going to be independent, meaning that they're following different distributions. So for example, the mean value mu is following a normal distribution, whereas the variance is following a chi-squared distribution with I think n-1 degrees of freedom. So they're following different distributions. But for a proportion, the variance is a function of the mean. So if you look at the variance, it's probability of success, or P, times 1 minus P divided by N, where P is the proportion and N is the sample size. So the P here basically is our parameter, or P hat rather. Okay, so because the mean and variance for proportions, the assumption of independence between the mean and variance don't hold for the t-test, right? And so that's why you can't use the t-test for comparing proportions. You need to use the z-test. And I'm not going to do it in this video. I just want to, first of all, I want to see who will believe that I can do a t-test for proportions. Now, okay, so theoretically, yeah, you shouldn't do it. That's not to say that if you did do it, would your results be much different than using the t-test? Now, that's a matter of experimentation. And so, you could try that. You could try that, and I'm not sure that you would experience much of a difference in that regard. Remember that a t-distribution, if you have infinite degrees of freedom, a t-distribution is in fact a z-distribution. So there's that. So let me just take a look here, because I think I might have both examples here. So let's see. Checked. So let me just check one thing before I end the video here. And it looks like, yeah, I did do this. Yeah, I did do this both ways, and you do end up rejecting the null hypothesis both ways. So there's that. Theoretically, you should not use a t-test for comparing proportions. Experimentally, however, it might be a good idea to try to figure out, like, just when exactly does it fail? Because in this case, I did it both ways and I got a reject. They got the same result, rejecting the null hypothesis. So that could be, that's a one-off, right? Could be a coincidence, but that's the general idea. That's the general theory. So that's it for this video. I hope it helps. And if there's something if you have a comment, suggestion, or something's unclear, please reach out and let me know. Thanks for watching.